Okay, in our topics today, we'll look at the upper and lower bound, and the learning objective is to find the limit of accuracy of numbers that have been rounded to different degree of accuracy. And this is our keywords. And before we embark on this, students should be familiar with all types of rounding and understand the 5 rules of rounding up. And students should also know the difference between discrete and continuous data. This we have done before. Okay, now if we are asked to find example, here it says that a stick of wood measured 8 cm to the nearest centimeter. Write down the upper and the lower boundary. If we are asked to find the upper and lower boundary of this, let's consider the number line. If I have this place to be 8, if I have this place to be 8, here 7, 6, here 9, and there 10. Okay, so for me to find the upper and lower bound of this, from here I will check from 7 to 8 what is the lowest number that can be rounded up to what 8. You can see that the lowest number that we can round up to 8 will be 7.5. 7.5 is the lowest number that can be rounded up to 8, because if you have 7.4, you cannot round up to 8. Is it not so? So from here we have 7, 7.1, 2, 3, 4. All those ones cannot round up to 8. It's only 7.5 is the lowest number that can round up to 8. Okay, so in the other side, we can look for what is the highest number that can round up to 8. We can see that we have 8. 8.1 can round up to 8. 8.2 can round up to 8. 8.3 can round up to 8, like that. So when we check something like 8.4 can round up to 8. So 8.4, 9, 9, 9, 9, 9, and so on and so forth. This will be a recurring decimal. This one also can round up to 8. So since we have this to be round up to 8, we can simply have this to be what? 8.5. If we round it up to this, we can have it to be 8.5, which means that 8.5 is not inclusive to round up to 8, because if we round 8.5, it gives us 9, is it not so? But when we consider 8.499999, if we round it up to, we have this to be what? 8. So here we can have this to be, so instead of us having 8.4999, we can simply have it to be what? 8.5, which means that in a number line, that 8.5 is included in the rounding up to 8, and 8.5 is not included. Other than 8.1, 8.2 to 8.49999 are all included. Okay, so we can have this inequality to be that 7.5 is less than or equal to the 8 cm, that is stick of wood measured 8 cm. Stick of wood measured 8 cm, and is less than what? 8.5. It is not less than or equal to, just less than 8.5. Okay, so this is how we solve it. But I will show you the simplest way to solve it. So the simplest way to solve it is just, first of all, find the half of the degree of accuracy. When you find the half of the degree of accuracy, add this to the measurement. If you add it, you have the upper boundary. When you subtract it, you have the lower boundary. Like here, we say that a stick of wood measured 8 cm to the nearest centimeter. So nearest centimeter means nearest 1 centimeter. Okay, so if you're asked to write down the upper boundary, here we know that half of 1 divided by 2 is 0.5. So if I want to find the upper boundary, for me to find the upper boundary, I will have that to be 8 plus 0.5. And if I want to find the lower boundary, I can have it to be 8 minus 0.5. So 8 plus 0.5 gives us 8.5, as we have here the upper boundary. and 8 minus 0.5 gives us 7.5, as we have here the lower boundary. So these are the shortest way to find it. Okay, now let's look at some example using that method. So here we are asked that write down the upper and lower bound of each measurement. For the first one, A says a distance given by 55, a distance given as 55 kilometer to the nearest kilometer. To the nearest kilometer means to the nearest 1 kilometer. It's not so. So half of 1. Half of 1 is 1 over 2, which is 0.5. So since I have 0.5, now if I want to find the upper bound, the upper bound will be 55 plus 0.5. If I want to find the lower bound will be 55 minus 0.5. So 55 plus 0.5 gives us 55.5. This is the upper bound. And 55 minus 0.5 gives us what? 54.5. And this is the upper bound. Okay, now let's look at the B part. B part says a distance given as 55 kilometer to the nearest 5 kilometer. Then the degree of accuracy is 5 kilometer. So half of 5 kilometer, that's 5 divided by 2. Half of 5 kilometer will give us what? 2.5. 5 divided by 2 is equal to 2.5. Now 2.5, for me to find the upper boundary, I will have it to be 55 plus 2.5. And to find the lower boundary, that gives us 55 minus 2.5. So the upper boundary, 55 plus 2.5 gives us what? 57.5. This is the upper boundary. And 55 minus 2.5 gives us 52.5. This is the lower boundary. You see that? So that's how we solve it. Then the C part also, in the other way around, says a stick of wood measured 32 cm to the nearest centimeter. Centimeter means 1 centimeter. It's not, so the degree of accuracy is 1, and half of 1 gives us 0.5. So in here, for me to find the upper bound gives us 32 plus 0.5, and the lower bound is 32 minus 0.5. So 32 plus 0.5 gives us 32.5, and 32 minus 0.5 gives us 31.5. So this is the upper bound and this is the lower bound. Okay, now the last one there, D, says what? A mass measured as 120 gram to the nearest 10 gram. Nearest 10 gram. 10 is our degree of accuracy. So half of 10 is 5. So 10 divided by 2, half of 10 is 5. Now for me to find the upper boundary will give me what? 120 plus 5, and the lower boundary is 120 minus 5. So 120 plus 5 is what? 120 plus 5 gives us 125. So this is the upper boundary, and 120 minus 5 gives us 115, and this is the lower boundary. That's how we solve it. Okay, now let's look at this question. Now this says write down the lower and upper bound of each of these value which are rounded to the accuracy stated. Now the accuracy already stated. From here it says 0.27 to 2 decimal place. If you ask to 2 decimal place, 2 decimal place gives us a degree of accuracy to 2 decimal place is 0.01. This is to 2 decimal place. If you ask to 1 decimal place, degree of accuracy is 0.1 to 1 decimal place. So record this, please. If you ask to 3 decimal place, the degree of accuracy is 0.001 to 3 decimal place. please recall this ones. So to 2 decimal place, we have it to be at 0.01. This is the degree of accuracy. Now, if you're asked to find the lower and upper bound, we look for half of the degree of accuracy. So degree of accuracy is 0.01 to 2 decimal place. Then half of it divided by 2 will give us what? Gives us 0.005. Okay. Now, for me to find the lower bound, the lower bound simply means 0.27 minus 0.005. This is lower bound. And then the upper bound is 0.27 plus 0.005. Okay. So the lower bound gives us, if I minus this, I will have 0.265. Okay. And if I plus this, I will have this to be what? 0.275. So this is how we find the upper boundary and the lower boundary. Okay. Now in the B part, significant figure, we have to be very, very careful with this significant figure. Now for me to find this, we are asked to find the lower boundary of 200 to 1 significant figure. Now if you look at this, to 1 significant figure, 1, if I cross it here, 1 significant figure, you can say I have double 0, which this is equivalent to say to what? To 100 whole number, and as to the nearest 100. So this 1 significant figure is just similar to say to the nearest 100. So if I look at this now, find out that the degree of accuracy there is what? Is 100. That's the degree of accuracy. Now half of 100 is what? Is 50. So for me to find the lower boundary gives us 200 plus 50, and minus 50. The lower boundary gives us 200 minus 50. That's the lower boundary, while the upper boundary is 200 plus 50. So 200 minus 50 gives us 150 is the lower boundary, and 200 plus 50 gives us what? 250. So this is the lower boundary and this is the upper boundary. Now looking at this one also, they say this is what? To 2 decimal place. To 2 decimal place. That's 2 significant figure. If I look at this to 2 significant figure, if we want to measure this to 2 significant figure, we have that to be what? 1, 2, which goes here. Since we have here to be 0, that means that this is just equivalent to say to the nearest 10. To the nearest 10. You see that? Then for us to find that, you know that the degree of accuracy here is what? Is 10. Then half of 10 is 5. Half of 10 is 5. Now for me to find the lower boundary, the lower boundary gives me what? 250 minus 5, and there the upper bound gives me 250 plus 5. So 250 minus 5 gives us what? 245, and 250 plus 5 gives us what? 255. So this is the lower bound and this is the upper bound. Okay. Now look at this. You have to pause this video, solve this also, and know if you have the answer correct. Okay, so now this is how we solve the problem. So since we have that each of the mass is 65 gram, that means that to the nearest gram means to the nearest 1 gram. So the half of 1 gram is 0.5. For us to find the greatest possible mass of 1, that means 65 is 1 plus 0.5, the degree of accuracy gives us this. For us to find the least possible mass, that means 65 minus 0.5. Then what is the greatest possible mass of all? So if we say all are 40, we have 40 to be all. So 40 times this is what? The greatest possible mass of 1. So 40 times this gives us this, and the latest is 40 times this gives us what? This. So that's how we